Hey everyone, in this video I'm going to capture the RF of one of these cordless doorbells here and then analyze what it's actually sending out, and then what I'm going to do is use GNU radio to transmit that. But I'm not just going to capture it and retransmit the captured RF. I'm going to generate the pulse and fully synthesize a new signal. So these here, they're pretty horrible compared to the one that I've got out there. But not everyone's got a big ding dong like me. So if you've just got one of these average little crappy ones here, I'll show you how they work so you can get the most out of them and still have some fun. And of course, you'll be able to press a button on GNU radio and set the doorbell off. So I'll go through that now. Okay, so on the desk I've got the HackRF currently running as the receiver and the doorbell button just to transmit. And on the computer I've got gqrx running, which is just simple receiver so I can see what's going on. Now I know it works in the 433 megahertz range, so when I press this button, doorbell, you can see the pulses that were there, okay? It's quite clear. Now one thing I want to show you as well, I've specifically got the doorbells away from the antenna, but if I bring them close, okay, now I'll just put one of them there. Make it a little bit clearer. So you can see there's RF energy all across there just sort of pulsing when I'm not pressing any button. So that's coming from this. If I take it away, it disappears. Now what that'll be is this will have a local oscillator so that, I mean, it has to be on that frequency to be able to tell if someone's transmitting, but I guess it just pulses it so it doesn't stay constantly on and drain the battery. But it's still transmitting some crap out very minimally just from its internal oscillator. So when I press the button, it was able to mix with that frequency and determine that someone pressed the button. Anyway, that's just a little bit of info there that I found while I was looking into this. So I'll just take that away. Okay, in fact that's pretty close too, so I'll move that back a bit. Okay, now in gqrx, what I can do is record a sample of the RF. So if I press record on here, then press the button. Okay, and then unrecord. Now I'll have a sample of that RF from when I press the button here, and I can analyze that. So if I go over to here and open inspectrum and the file I just recorded, open that up, and this is like looking at that waterfall display. So what you see here going downwards in this direction, it's going from left to right up here. So if I just look for the pulses when I pressed it, oh, there they are, loud as hell. You can see the pulses. I'll just clean that up a bit. So the minimum power, get rid of the background. Oh, the max power. It's pretty overloaded here. Let's see if I can make that as neat as I can. That's all of them. Okay, so that's one complete pulse train there. So what do we got? We got a mess because it's just too powerful. Oh, that's a bit better. So you can see we've got short ones and long ones with some gaps in the middle. So some gaps are bigger, some are smaller. So I've got to try and figure out what we've got here. So what you can do is just put a marker on here. And before I do anything, I'll set the same sample rate that I used in gqrx, which was 2 megasamples a second. So what that does is makes the measurements accurate here. So between these markers, I now know the time, the duration of whatever I'm looking at here. So let's say one pulse is there, and then including the gap, you've got the next pulse there. Set a few of these markers up here to cover the symbols. So now I can do it over a bigger time period and account for the drift that it might have. So you can see I'm lining each of these lines on the start of one of those pulses till however many I've got, which was, how many? No, it doesn't quite fit on the screen. So there's 25 pulses all up. Yeah, I'm gonna have to zoom out a little bit just to fit them on. Okay, there's 25 pulses, and then there's a bit of a gap, and then it starts again. So what I would do is I'll just call a short pulse a 0 and a long one 1. So I'll go 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 0, 0. Is that what you got? Okay, so that represents those pulses. I'll just keep that to the side. And we can see that they're 688 microseconds apart. Okay, that's what we know about them. So I'll just take some notes about this. Let's call it 690 microseconds, because I don't think that's going to make too much difference, 2 microseconds. There's 25 of those pulses, 25 pulses, but we also have a gap here as well. So if I look at the space after that one, I'll see that there's 1, 2, 3, 4, 5, 6, 7 spaces before it starts again. So 7 spaces, which seems to add up to a nice round number, 32. Of course, that's a clean number in the digital world. So that's what we got. So I want to reproduce that. And just looking closer at it, I'll zoom back in. It looks like the short pulses, they're on for just under half of the duration, and the long pulse takes up, well, like 80% of it. Okay, so let's say a short one's, I don't know, 20, 30% or something, and a large one's 80. So I'll work with that and see if I can make a pulse. Okay, now I'm going to start at the absolute start. So here's a brand new file. Now, first thing it's got red here is it doesn't like something, so it doesn't like the name default. So I'll call it Doorbell. And the sample rate I'm going to use is 2 meg sample, so 2 exponent 6. So that's like 2 times 10 to the power of 6. So when you press it, it comes up here 2 meg anyway. Okay, so the first thing I want to do is create a vector. So just Control F, vector source. Okay, with vectors it just means like what sort of value. It's just a bunch of values essentially. So I want this, if I make that 0, 1, 0, 0, 1, 1, that for instance, that'll make a vector source. Now blue's complex numbers, I don't need that for this. I'll just use up and down until I get the orange for floats. Okay, now on the output, I'm gonna put this to a time sync, again making a floating point. And I will need a throttle, because what'll happen, there's no hardware involved at the moment. This is all software, so that's generating software. This will display in software, and it'll run as fast as the CPU can do it and hurt itself. So what I'll just do is put a throttle there to make sure it only goes at 2 megasecond. Okay, so I've just saved it as test. If I just show that, what you see is nothing special. Zoom in on the X there, you'll see that all these samples, if I stop that, you'll see the same sort of vector that I had, 0, 1, 0, 0, 1, 1. So it goes from 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, then back to the 0. So it just toggles between that sequence. It just repeats that sequence. Okay, so you get the idea. I'm just creating something with amplitude according to that vector. So that's what the vector source does. But if we go back and look at those pulses, none of them are on for the whole duration, and so I have 2 different pulse lengths, one for a 1 and one for a 0. So what I'm going to do is I'm going to make it so I can adjust this pulse width here. Okay, so what I'm going to do is create a little control here, a range. So just search for range, UV range. Okay, and I'm going to call it duty cycle high. And its default can be, I'll make it 80. And I can toggle it from 0 to 100 with steps of 1. So that's duty cycle high. And I'll just copy that, make another one called duty cycle low. And I'll have its default value at say 20. So I've got a couple of different slider values. But I won't do anything at the moment. It just gives me these controls here for a high and low. So what I can do now for the vector source, okay, so for these values, I want the duty cycle high value, so duty cycle high, and I want that many ones. So what I've actually got to do, otherwise it'll get upset, is make sure it's an integer, because it messes around with different types and Python will get upset. So that many times ones, okay, I want that many ones, and then I want the rest of the 100%, so 100 minus, duty cycle high. I want that many zeros. Okay, so if I run that, what you see, I haven't done the low cycles yet, but duty cycle high, this is basically 100 samples between, oh, I'll just stop this. Pause that. So what it's doing is, let's say it starts here from that vector source, I'm doing 80 of them and then 20 zeros. So that's what it's producing there. And that gives me the ability now to just change this, and you can see the pulse width is changing right down to obviously 0 or all the way up to 100, which is constantly on. So that just gives me some duty cycle control. That's the high one. So what I've got to do is do the low one, which is simply a matter of, I'll just copy the whole thing. Oops. Of course you've done it like that, haven't you? Same sort of thing, but down low, and what I'll just do is change this high to low. So now you get an idea of 2 pulse trains. So the duty cycle high, which is, I should have labeled them, it'll be this one down the bottom. You see, as I change that, down the bottom, the duty cycle of that one changes. So I've generated 1 pulse stream and another one which I'll use for the zeros. So I can have 2 different pulse widths for 2 different things. That's just the way I'm doing it. Okay, what I'll do is I'll just disable that, just D for disable, and I'll make another vector source. Okay. Another vector source, but this time I'll put my actual vector of what we saw before. So the real vector will look like this. They're the real zeros and ones. And if you remember, there were 25 of them. 25 of those. Okay, so there's 25 of these. Once again, make that a floating point. Now, for every one pulse up here, we've got 100 samples because I'm using it as percentages, right? So I need every zero to be worth 100 of these, like to go for as long as 100 of those, and then the same for the 1, and then the next 0, and so on. So what we can do is run a repeat. Okay, so I feed that to the repeat and make it 100. So for every pulse, for every digit here, it puts 100 of them out to match a 100% that's coming out of this. And instead of going to that throttle, what I'll do is I'll go to the multiply. I'll multiply them together. So now there's our constant pulses coming from the top, and here's our actual code. So when this is a 1 up here, then it will allow this through. Oh, sorry, other way around. When this is a 1, it'll allow that through. So now, if I do that, this will only work for the 1s, obviously. Forget the zeros for now. If I run that, we've got something looking a bit like something now. Let's extend that out. So that's representing the 1s. And I've kept them at 80%, but of course I could muck around with that, but I wouldn't because I'm going to leave it at about 80. Okay, so now that's pretty much done for the 1s, sort of, for now. But I've also got to do the zeros. Now the zeros down here, if I enable them again, here's my zeros source. What I have to do is, I've already mastered this, so when a 1 goes through here, it mixes and allows the high ones through. So I need it to say that when a 0's here, to let this vector source go through for the short pulses. So what I'm going to do, I'm going to start with a constant and float. Constant 1. I'm going to start with a value of 1 from this source here, and I'm going to subtract. Oh, shut up. Subtract. Okay, so probably get rid of that for now, and probably that as well. So this vector source, the same signal is also going to this subtract from 1. So the output of this, if that's a 0, 0 from 1 is 1, so then I will get a 1 output. So it's basically inverting it. And if it's a 1, well, 1 from 1 is 0, so I won't get an output. So only when this is a 0 will I get an output here. Okay, so just copy this multiply because I need another multiply. So now I want that to be multiplied with that source. So now I have my negative pulse. And if I just move this out a bit and have both of them going here, so just add them together. So there's my positive pulses and the negative ones. And put that in the throttle and see how we go. So now it's looking a bit better. Again, I'll put the control panel on, zoom out a bit so you can see, stop it. Okay, so now you can see I've got some long pulses and short ones, and they were set because of the duty cycle high and low values. Like if I run that, I've still got that control. Like if they were both set to 50%, you wouldn't really tell which one's which, but make the low ones nice and thin there, and a high duty cycle for the ones. You can see it take shape. So that's pretty good, but not there yet. Because if you remember the actual signal, there's a gap after that. Remember those from the notes? Was it 5? The 7 spaces? So there's 7 spaces worth of gap here as well. So what I will do is have another constant source. Okay, a constant source, this time for 0, so I'll leave it at 0. And just move that out of the way. This time I want most of these to go through. The output here that you just saw, I want that to be there most of the time, but then I want some zeros. So what I'll do is I'll use the stream mux. When I find it, stream operators, stream mux, where are you? Right here. Okay, so what the stream mux does is it takes it in turns from its input to what goes to the output. So if I just had one from there and one from there, with lengths of 1, 1, it would just go one of those to every one of those. Now you could make it 3, 1 would mean 3 from this side and then 1 from there to the output. So 3 from this, 1 from there. Now I've got to think about what I'm actually doing here as far as timing goes. Now I'm using 2 megasamples a second, which brings me to 500 nanoseconds. Let's just get the old calculator. So if you've got 1 divided by 2 meg, you will get, shitty calculator, you'll get way down here, which is millimicro nano, 500 nanoseconds. Okay, so half a microsecond. That's how long each pulse would be worth when you're sampling at 2 megasecond. So coming out of here, this is going to be way too quick. Each pulse is going to be, 500 nanoseconds. If I just, let's have a look. And just something else you got to keep in mind with StreamMux, even though it's presented like this, you do need a square bracket at the start and the end of that in these newer versions. That had me stumped for a little bit. So let's say if I've got 25 symbols coming from this, remember I had the 25 of that and I wanted 7 spaces. Remember I took the notes, there were 25 pulses and then there were 7 spaces. So if I have that as 25 and then 7, it'll do 25 of those and then 7 of those. 25 of those, then 7 of those. But we don't have 25 and 7 because I've times them all by 100. Remember, because there's per percent. So 2500 and 700 of those. So now if I run that, let's get this control panel up, zoom out a little bit, you'll see that's starting to look a bit more reasonable. So I have essentially the same pattern that, where's my thing? I'll just try and get that somewhere over here, blah, blah, blah. You'll see I should have a similar pattern of short, long, short, long, short, 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 long, blah, 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 and then this gap. So that's looking pretty good at a glance. The only problem is, look at the time. We had basically 690 microseconds between these pulses, whereas on here, one pulse, 1452, 1450 the next, it's tiny. It's going to be, where are we? It's going to be 100 times the actual sample pulse. So remember, for that 100%. So we're down to 50 microseconds. So 50 microseconds for a pulse, but I need it to be 690 microseconds. So how am I going to get around that? Well, what I will do, again with the repeat, what have I done? Okay, coming out from that stream mux, what I'll do is I'll repeat that a bunch of times to make it last longer. So I'll just repeat them. Bang, bang, piss that one off. Repeat that. Now, how many times do I want to repeat it? Well, I want a variable up here for the symbol period, so I don't have to think too hard in the future when I just want to copy that symbol period. So I'll just put another variable up. Where'd it go? And I'll call this symbol period. Now the value is what I've got on inspectrum, which I'm just going to say is 690 microseconds. So 690 exponent -6, 10 to the -6, which is micro, and it comes up there with a little, it's supposed to mu. So 690 microseconds. Okay, so now I've got a variable that I can just punch in here for different things that I might analyze. And so I want to repeat. It's got to be an integer. Okay, so there can't be any decimal points involved here. So I'm going to use the symbol period divided by the 1 divided by the sample rate times 100. So the sample rate. So the sample rate, which is up here, is 2 meg. 1 over that sample rate will give me the each sample size, which was 500 nanoseconds. Jesus. 500 nanoseconds. Times it by 100 for the fact that there's 100 per pulse, and I get 50 microseconds. So there's my pulsing that it's just worked out. And to get to the amount I want, the symbol period, I divide that. So symbol period, what I want, divided by what they actually are, will give me this integer that I need. So when I do that, it says, you're an idiot. So what have I done wrong? Oh, I'm an idiot. Sample rate is the variable name up here. Sample rate. Okay. There we go. So now, if I run that, give me some controls. I'll just have a look at one of these pulses. So between here, let's say it starts at 500 microseconds-ish, and it goes until the next pulse, which is here. It's about 600 and something microseconds. So at a glance, that looks like it's about right. So these pulse widths look pretty good now. So that's the digital part of this done. Okay, so that's all digital. I haven't done anything with RF yet. So what I'll do now, instead of going to the time, I'm going to make just a virtual sync and source. So all these are is just a way to continue your diagram. So if I put that into the sync, I'll call it a join. Okay, and that will come out at the other one called join for the sync source. So I can just go down here now. So what feeds into this sync pops out at source. So I don't have to have a big squiggly line across the screen. Okay, so now all I've got to do is get that to the RF output. But the SDR transmitter, the HackRF, needs complex numbers. So I'm just going to use a converter from float to complex and just put that input. I only need the one there. And the output is going to go to use the Osmocom sync, which is the HackRF itself. So the parameters on that HackRF, as you know, the frequency is 433.9 megahertz. Just keep these 0. I'll give it 10 for IF and 0 and 0. Now what's going to go into it? Well, what I want to do is this digital pulse is only going between 0 and 1. I want to make it go between 0 and 10. So what I'll do is I'll multiply it. Multiply constant. So I'm multiplying it by a constant, and then it'll go in. That constant though, I don't want to be just 1 or 10, I want a button on here for control because I don't want this thing to be going non-stop. So if I put a button in, or just a button, and I will call it, I'll just call it button. Okay, now its default value is 0. I'll make it when it's pressed, its value is 10. And now for this constant, instead of being 1, I'll just call it button. So you see it's 0, but it'll be 10 when I press the button. So let's see what goes on. If I run that, okay, I don't need the doorbell, I need the actual bells. This is going to be a transmitter now when I press the button. And there it is. So, completely synthesized the pulse train. And as you can see, there's not much really RF. All that's doing is telling this when to transmit. It's just an on-off keying, so it's just turning this on and off the transmitter. Most of it's the digital setup. Now, the proof of the pudding is in the eating, so I could say that works and be done with it. But what I want to do is get a second opinion. So independently, I've got another SDR receiver, because I'm going to use that HackRF to transmit, so I can't transmit and receive at the same time. So what I'm going to do on this is do another capture of my generated pulses just so I can have a look at them as well. So same thing as I did before. Start recording, press the button, and stop recording. Okay, so now I've got that, and I'll just send that over to the other computer so I can look at it on the big screen. Okay, so the zooming's a bit different, but the top is the original from the actual doorbell button, and the bottom one's my generated one. And my symbol period is a bit smaller, and that's probably because it was a nice round integer number when I did that repeat up here. I had to use an integer of that, so I would have rounded it to the closest thing. But you can see obviously it's there and it works, so it's not too fussy about that small difference, which I could have tweaked if I really wanted it to be. But anyway, it works, and that's the main thing. I just wanted to check it and show that it looks somewhat similar, obviously. I also recently got a roller shutter installed on my bedroom window there to make it nice and dark. And I specifically got the RF controlled one, okay? And of course this remote works in the same frequency as well. So when I press this, you see a pulse train come up here, okay? Just some pulses going up there. Now, obviously my plan was I wanted to do the same sort of thing, get the pulses, create it, and then make it so I could integrate this with Home Assistant. So let's say at 8 o'clock in the morning or something, I could just make the blinds come up that way sort of thing. But as it turns out, these use a rolling code like garage door remotes do, which surprised me, but then I guess it doesn't surprise me because they're security shutters as well. Some people have. So what I'll do is I'll just do a snappy capture of this and show you this. So when I record, press the button, stop recording, and I'll load that up and show you. First thing you notice is it's a lot longer than the other one. It does repeat though. So you can see the preamble, which is just a whole bunch of the same bits here. Where's my thing? And then it changes, there's the actual code, and you'll see it's repeating here again with those bunch of similar ones. So it's about between there and there. This is the code here. And what I found, with each button press, that code is different. So that ruled that plan out. So there it is. And as I pointed out before, if you've got an antenna on the roof, you can pick up half the neighborhood and see what's going on, because a lot of things use this frequency. And if you've got another antenna and a transmitter, you can transmit stuff as well if you want. But, you know, I can't be bothered, but I could do. Anyway, that'll do for now. Until next time.